Hi there, welcome back. If you've been following my videos, and especially if you saw the last restoration of that tube radio, you'll probably recognize this guy. This was stuck in the back of the tube radio as an appendage. Obviously was not supposed to be there, or didn't seem to belong there. And just to make things even more confusing, the way they'd wired this up was really weird. The output from this, or what seemed to be the output, was actually connected to the antenna input of the radio. The power came from a shared wire with the gramophone, and the main tube that you see on the top there was totally devoid of any markings. It had 4 controls on there, one of them being a switch, which was obviously the on-off switch. Then there were 3 more potentiometers, indicating almost a tone and volume control section. It has 2 tubes, what looks like an output transformer, filter capacitor, selenium rectifier at the back. Quite a hefty transformer with a voltage selector on it and the fuses. So this thing looks and looked pretty self-standing and pretty complete, whatever it was. Turns out it wasn't such a mystery after all. And here you see why it's important to have subscribers. One of the viewers, one of the subscribers, actually sent me an email with this, which quite honestly I'd never heard of. Apparently it's quite a well-known record player. And if we look further down, you'll see why this thing caused quite a bit of excitement. See that over there? That is exactly what I have here. And what this turns out to be is the power amplifier section for this record player, which apparently actually had some airtime on a very popular TV series. I believe it's The Avengers, if I'm not mistaken. And this thing is exactly what I'm looking at. Not only did he send me that description, but he sent me the actual circuit diagram, complete with a description on how to dismantle it and so on and so forth. And we actually have exactly this circuit diagram reproduced in that equipment. There's no change whatsoever. I've checked. What I had done is I started looking at the output section. I actually drew this part of it. This is where I concluded that this was a power amp, because this tube fit the description, at least the connections to this tube, to the tube that were on there, which I couldn't read the markings on, fit the connections for a tube that I've used before, and I've found on a couple of radios I've restored, and it's an ell80 used in some, especially German sets, as a single tube push-pull section. So let's look a bit closer at how this schematic develops. If we go to the end and work backwards, we find there's really not that much of a mystery. You have your AC coming in here, goes through a fuse. It's one of those fuses on the top there. There is actually a socket at the back where the AC gets redirected to. That is indeed there. It's that black 3-pin socket. That's usually for the gramophone itself, the motor. The power comes in. You got your voltage selector, which we've seen on there. And then the transformer has 2 secondaries. The first one feeds the selenium rectifier over there, and it's supposed to produce 276 volts. Driving 50 milliamps. The second secondary is the heater supply at 6.3 volts. Both of those are referenced to ground, which is the chassis. Then the power goes through a second fuse, a smaller fuse, goes to a filter can. That's one section of that filter capacitor we see on the top there. There is a resistor feeding the second section of the filter can, another 50 microfarad. So this is one capacitor with 2 sections in it. The B+, first B+ is actually here, which comes to the center of the push-pull output transformer. That in turn has a secondary that is connected to an output for speakers. Now it does say 15 ohm speakers, which is not something I have, but we can sort that out. There is also a tape out socket, so basically you can take your signal out for recording. That'll be one of those other RCA type sockets we have there. We see one more connection going from the output of the speaker all the way around here, and that goes all the way up there, and we'll see what that does. That's negative feedback. If we follow the push-pull section, we have the screens of the two pentodes, pin 9 and pin 1, connected to the second B plus over here. Now this is indeed an ell80, very rare actually, quite expensive to get hold of these days. So it's two pentodes in one tube. The plates each feed one side of the push-pull transformer, which means that we then have to have equal and opposite signals coming into the grids, pin 6 and pin 2. These have grid stopper resistors of 47K, this one over here. There is one cathode resistor, so this one is cathode biased. The cathode, it's a single cathode, or the two of them are wired together. That's pin 7. That goes through a 160 ohm resistor to ground. Then at the inputs, at the grids, we've got a 1 meg resistor to ground on each side, and our signal comes through, or the two versions of the signal which are required for push-pull come through these two capacitors, that one there and that one there. Those are 47 nanofarads. What we have preceding that then must be a phase inverter, and this is where this first tube comes in, which is quite an odd one. This tube has a pentode and a triode, and they've used the triode for the phase inverter with a 100K resistor to the B plus, B2 plus, and another 100K resistor down here, so the signal is equal and opposite on the two ends. That's exactly what you need for push-pull. What they have here is the grid resistor 1 meg is fed through this decoupling cap or coupling cap, 10 nanofarads, to the anode of that pentode over here, which is the other half of the tube. That has a 470K kilo ohm anode resistor with a 220 picofarad capacitor across it. That'll be to reduce high frequencies, probably to control oscillations. You would then have the screen grid connected to B plus through a 2.7 meg resistor. You have the grid itself on pin 9. The cathode goes through 22 ohm resistor, so this cathode is 22 ohm resistor to ground, and that receives the negative feedback from the speaker over there through R7. The input then comes from the wiper of the volume control, which is one of those potentiometers. There's a 5.6 meg grid resistor here. That volume control is fed by this circuit here, which is a tone control, and you have one pot for treble and one pot for bass. Pretty straightforward. That then goes to quite a complex input jack, and the reason for this is you can use the stereo jack input, or you can use a pickup input that's at the top, and one tends to switch off the other, which is to avoid noise. And this is exactly what we have there. I've checked. Components match, everything matches. The circuit is pretty straightforward, and this is what I'm going to use to do the restoration. Now, to make it simpler, I'm just going to restore it. I'm going to check the transformers, see that they work. If the transformers work, then I know I've got a viable project. I do have a spare ell80. I don't have a spare 6BR8, which is what this tube is. So I need to make sure that's working as well, because if I don't, if that is not working, I might have a bit of a problem. The one thing I can comment on this, which is a bit strange, is that you've got your signal coming in here, and before any amplification happens, you've got all the tone controls. And tone controls, if you understand how they work, are really attenuators. So the signal is getting tampered with, reduced as it were, quite a bit with these tone controls before it even sees the first amplification stage, which is this part of the first tube. So I'm not sure how it's going to work. I'm not sure how it's going to sound, but it's neat. So I'm just going to go ahead. I'm going to do it. I'm going to do the restoration, and then we'll get back and test it out and see what it sounds like and see if it's useful for anything. Okay, so with all that done, as you can probably see, the change is quite dramatic. This thing is back to a little bit of glory, nice and shiny, everything working hopefully perfectly, and we're ready to do some testing. I've obviously done a power up test and everything else. Everything's working beautifully. On the power side, we were going to look at what an audio signal looks like on this. What I've got here is I've got a 15 ohm resistor acting as a dummy load taken from the speaker outputs over here. I have a 1 kilohertz sine wave going in here at 100 millivolts, and we switch it on. Here's the volume control. We won't hear anything, obviously. We'll see it on the scope, and I'll show you that in a minute. This is treble, and this is bass. So let's have a look at what we have. And there we go. I've got 1 kilohertz coming in, 100 millivolts RMS, and what I have there is a beautiful 4.3 volt RMS sine wave. Now this is on not quite maximum volume, because as you can see it starts distorting over there. You started to get some distortion when you go a bit further than 4.5 volts more or less RMS. Now that means 4.5 squared divided by, what is it, 15 ohms load. Hey, do the math. It is not a very powerful amplifier by no means. So it is it's there for the purpose. It was there to give a secondary output to a record player. In other words, to make the turntable or the record player play in stereo. Now what we have here, the 1 kilohertz, if I put this up to 150 millivolts, let me drop that, you start seeing it rounding off. Now that's obviously clipping, or that's obviously distorting quite badly. However, there's something interesting here. The distortion is very smooth. It's not a sharp cutoff as you would say with a MOSFET output stage or a transistor output stage. And this is really a demonstration of the characteristics or the desirable characteristics of a tube amp, in that when the output stage distorts, it does so in a tube-like fashion. This is tube distortion at its best. It's actually doing the top and the bottom practically at the same time or level. And if I drop that back to 100 millivolts, there we go, 100 millivolts. I can get the same distortion obviously by keeping the same 100 millivolt input and increasing the volume pot. There we go, distortion. Now for hi-fi, that's definitely a no-no, but there is something that would actually benefit from this kind of distortion at low volumes, and I'll show you that in a bit. What else do we have here? We have our treble is on max, our bass is on max. Very little effect because the treble level, it does affect it somewhat, but not much as I'm turning it there, because 1 kilohertz isn't really up at the high treble levels, and it's also not down at the bass levels, so therefore you don't have much effect on bass. Now let's try something else. Let's get this down to where we have a clean sine wave. Let's call that, actually I'll tell you what, let's call that a clean sine wave. That is 3 volts RMS. It can go a bit higher, but for the purposes of what I want to do now, I'll leave it there. And what I'm going to do now is drop the frequency. We're at 900 hertz. Let's drop it to say 400 hertz. 400 hertz, 3.4 volts, so slightly higher than our 3 volts. So we've actually got this thing increasing in amplitude as we drop the frequency. Let's go down further. 300, 200, there's 100 hertz. At 100 hertz, we're at 5 volts RMS. So as you can see, this thing is actually boomy at the bottom end. We've actually got the frequency response a bit messed up because it's actually a lot more responsive at the low frequencies than the high frequencies. Let's do the opposite. Let's go back to 1 kilohertz. As you can see, there's a bit of hum on there, probably because this tube is not hasn't got the cover on. I've misplaced it somewhere, but anyway. Let me try 2 kilohertz. 2.99 volts. 3, look at that. 5, 6, 7. Now, look what's happening here. At 7 kilohertz, we're down to 1.5 volts. So we're down to half the amplitude at 7 kilohertz. So this is definitely not hi-fi. You should have a straight frequency response, a flat frequency response. When I'm up to 10 kilohertz, I'm down to 1.1 volts RMS, 1/3 of what it was at 1 kilohertz, and significantly lower at what it was at 100 hertz. So hi-fi it definitely is not. The other thing is we've got some hum. If I turn the signal off and come down, there's our 50 hertz hum. It is indeed 50 hertz, not 100 hertz. So this hum is not from the power supply regulation, because that would be 100 hertz. It's definitely coming from interference with the components that are exposed out here. My guess is it's actually the preamp tube, the 6BR8 tube that's acting as a preamp and then a phase inverter, because that's sitting there exposed to the atmosphere in a very, very noisy, electrically noisy environment, which is this bench over here. So we do have quite a bit of hum. It is not really audible at the levels we're playing, but it is there, definitely there. Now, when I said that this frequency response is actually quite beneficial to something, that something is actually for guitar use, which is something that one of the viewers mentioned, that it would make a very nice little guitar amp. So what I've done here is I've connected what is effectively a amplifier modeling pedal. This is one I designed myself quite a while ago, and I've connected this, the output of this, to the input of that. Now what I've got at the moment is a clean signal. In other words, the guitar is connected to the pedal and it's completely bypassed, so there's no effect to the pedal at the moment. And what we get, this is basically the clean sound. And the result is quite a nice grit. It's got quite a nice grit to it. I can control the amount of distortion, obviously, by the volume pot on the guitar. So if I put it low, it's quite clean. If I give it full volume on the guitar, what you get is it's a tube distortion, and it's happening on the power tube at low volumes. I don't know how loud it sounds on the recording, but in here it sounds quite low. It's actually quite low, so I can get quite a nice effect for a practice amp. Now if I apply this, then I've got control on the level that I'm putting into it, and I can go from clean to crazy distortion. This thing has got quite a bit of gain. You've got your low, mids and highs. This is your tone control. Put that in the middle. And gain, put that in the middle. I've got this at about 12 o'clock. And it sounds quite good, actually. It's a great crunchy sound. It's not unpleasant at all. I can go crazy with this thing because then I'm basically putting as much gain as I want before the power amp, which is cheating. And I can then drop the level. But if I want this thing to work as a clean boost, this pedal working just as a clean boost, I put the gain on minimum. I can give it more level. What I'm doing is basically buffering the guitar signal, which is high impedance, into a fairly low impedance input over there. Can't remember what the exact input impedance of that is, but what you want is a very high input impedance for a guitar, or you lose your trebles. This thing is doing just that. It's basically buffering it, and I'm getting the distortion from that tube. And my guitar playing is atrocious, but the sound is great. And I have a friend who's going to go crazy because he's a guitarist and he loves all these new gadgets and anything that'll give him some better distortion to practice in his apartment. As you can imagine, running a Marshall head, 100-watt Marshall head to distortion in an apartment doesn't make you very popular. This thing probably will. Now, I'm not saying this is going to remain as a guitar amp. I'm not even sure I'm going to put it into any kind of cabinet. At the moment, this is what it is. I can use a modeling pedal. What this is doing really, because of the cutoff from about, 7 kilohertz onwards, really, this is exactly what a guitar speaker cabinet will do. Guitar speaker cabinets generally have a cutoff at a fairly low frequency for hi-fi enthusiasts anyway, because the guitar doesn't go that high in terms of frequency, but it does give you that rounded sound. And added that to the rounding off that's happening in the power tube, this is a brilliant little push-pull, single channel push-pull guitar practice amp, with or without a pedal in front, and it seems to react very, very well to pedals. So that's a big plus. That's all you're going to hear of my playing, because this is embarrassing. I hope you enjoyed this. I hope this was informative. If anybody comes across one of these, they certainly are worth restoring. It's got a nice little push-pull output transformer. Power transformer is certainly doing the job. That tube is amazing. I know they're difficult to find, but it does do a good job of giving you tube distortion for guitars, obviously not for hi-fi, at low power. And I'll see you back soon.